Hello there. Hope you're all doing well. So today we are going to predict housing prices using our data set. So I have this data set which I downloaded from the kaggle.com, which is a website where you can get a lot of data sets. And I'm using this data set called Boost and Housing data set. So it has data which has about ranges from about 2016 to 2017. So here you can see that we have training and testing data. We have this train and this is test. I'm using the train one. I'm not going to use both of them. That would be a little bit lengthy process. So I'm going to use the train one. You can use any of them. Let me just load the data set and then I will tell you what each of the column means and that we have in the data set. So first of all, we're going to import the essentials like the pandas library and then we are going to declare a data frame which would be pd dot read csv, and so we have this data set called as train, as you can see here. So I'm going to load that in the Jupyter notebook, and then I'm going to read the head of it. Head basically means the starting first four or five rows. So as you can see, it will give me the first five rows. So here I can see that we have the ID. This CRIM stands for. You know what? I'm going to tell each one of them rows over here. So sorry, the columns. So crime means the crime rate in that area. These are the zonals or the residential zones, and then we have the Indus, which is basically the businesses around that town. Then we have the CHAs. I'm not sure about this one. It is Charles River Dummy variable. So I think there's something related to property, or I'm not sure. Then we have NOx, which basically means nitrogen oxides, which are harmful gases in the atmosphere. This is the amount of the NOx. We also have that in the data set. Then we have the RM, average number of rooms per flat, per house, or per apartment. Then we have the age of that houses in that area. Then we have the distance of the employment centers from that area. Then we have the radial highways, and then we have the taxes, pupil teacher ratios like the school students, and then we have the ratio of the black people in their town. Then we have the lower status of the population. Then we have the MEDV. So this is basically our target variable. So what does MEDV stands for? It is if, for example, let me give you an example. Okay, if MEDV value for a neighborhood, like for a town, is $20, right? If it's $20, it means that on average, homes in that neighborhood or in that town are priced at $20,000. So it is basically the median of all the prices in one single town. So if I say, you know what, the median of let's say there's ABC town, its median is 5, right? So that means that average price of each house in that ABC town is $5,000. So this is our target. We are going to find this using machine learning algorithm, machine learning model. So you know what? I think we can already. Let me check how if there we have any kind of null values in the data set, right? Because that would not be helpful uh, for the model. So we don't have any. As you can see, all of them are filled and there is no empty. So we can start the process of separating the data set into testing and training data sets. So first of all, we are going to create an X, which is basically the features, right? So what features do we want? We want all of these features. As we can see, they are all integers, so we can take all of them, and we don't want to take this one because this is our target. We want to find out this one, so we are going to ignore this one. And the easiest way to select this kind of thing is that you can say that df.drop, which will basically drop a single column. And which column do you want to drop? MEDV, because we don't want that for the features, right? X are the features, and then the access for it would be 1. So that would be, no, sorry, I think it would be 0 for the columns. Let me check it. I think it's not, if I'm not wrong, let me check it. Where is it? MEDVLST. Yes. So Let me run it without this one. No. Why is it giving me error? Not found in Access. Yes, you have to specify that it is the column, right? I think you have to specify, yeah. So I'm going to do something like this, and then let's see what happens. Yes. So as you can see, the MEDV column has been dropped, and we have all the other columns, right? I think we are also going to drop the AD. We also don't need this one. Um, yes. So now I think it's fine. And then for the target, we are going to select only and only the MEDV. So why would we one single series of an array, or you can say it is an array of values of the median values. And then what we are going to do is we are going to import the linear regression model. Sorry, the train test split from sklearn dot model selection. Wait, let me just load. It's really slow. I don't know why. It doesn't take that much, but today it's taking a lot of time. I was practicing before this video. It was taking a lot of time. I don't know for some reasons. So I'm going to import uh, train press split. So this is basically a function or a method where we can separate the data, which is this one, into um training and testing data sets. So I'm going to say X train, then the X test, and then we have the Y train, then we have the Y test. So and then I'm going to say train test split, and sorry, test split, and then I'm going to pass the X, which is this one, X, and then I'm going to pass the Y, which is this. And then I'm going to say that the test size would be 3%, 0.3. So I would say that, you know what, I want to keep the 30% of the data for testing and the rest of the data for training. So, and then the random state would be 42. You can select any digit over here. So basically it selects random data according to this number. So it's kind of an iteration. So, and then I'm going to run this. And then if I check the X train, as you can see, we have the random sampling 22, 284, 294. That's randomly split. It randomly splitted the data into training and testing. So now what we are going to do is we are going to import a model from the sklearn. What model do we want to use? Let me just linear model import linear regression. I think linear regression, yes. So linear regression, and then I'm going to declare an instance of linear regression, and then I'm going to pass the. So basically, I'm going to fit. What does fit does? Trains the model. So I'm going to train it on the training data. If I check it, as you can see that it takes X and Y. So X train and Y train. It takes the X train, which are the features, and the Y train, which are the target variables or the labels. So if I run this, let me check X train, Y train, so it's perfect. And then it would take some time, and then it has trained, the model has been trained. Now I can say that, you know what, I'm going to predict predictions. I'm going to print out some predictions from this model. So I'm going to say model dot predict. I want to predict it on the testing data. Which were the testing data? The X test, right? So if I run this, now if I check the predictions, it would give me some random values. So basically, these are the values that it predicted, the median values, the MEDV. It predicted these values according to the features. Now, how do we know if these values are correct or not? Well, we can test it. We can create a testing data, one single data for a house, and then we can say, you know what, give me the MED value of it. If that value is correct, then we can say, you know what, the model is accurate. If that is not the case, then there might be some kind of issues with it. We need to import more data for the model. But you know what, let's stop talking and do some stuff. So I'm going to copy. Where is it? Where is it? If I print X train, what do we have here? Because these are the features. So I have to pass all these for a single house, right? So all these columns for a single house. I have to specify what I mean is if I have to say test data is equal, this is one single house data, right? So I would have to pass all of this into the model if I want to predict a house price. So I'm going to do this. Just, it's a very lengthy process. I don't know why it's a kind of because these there are a lot of features involved in here. So you have to put the commas and the codes around each and every single one because Python has a lot of issues with the syntax systems. So it's really syntax sensitive, you can say. While on the other hand, if you look at JavaScript, it's totally opposite of the Python. Like you can have errors and the code will still be working, which is really impressive kind of. But anyways, so basically what I'm doing right now is I am creating a testing data for a house, right? And I'm going to take this, the first one, which is 0.0. I'm going to take this data. I'm doing just for testing. You can put any values over here. 75.0. Then we have 2.95. Then we have 0 and 0. Then we have this. And for the RM we have 6. And then we have 21.8, 5.4011. Then 3 and 252. So I have 3 and 252. Then 18.3 and 4.32. Okay, so let 4.32. So it's a very simple array. As we can see that the actual value of this house is this one, right? No, sorry, it's not this one. Why am I saying that? So we don't know the actual value or the value of this. Let me check it the in the actual array, which is this one. So let's see. If I say data frame.I LOC and I say 22, what does it gives me? So as we can see that this is the array and it has a median value of 30.8000, right? 30.8000. So let's see if the model predicts it. So I'm going to say test data frame and I'm going to use the pandas built-in method, the data frame, which converts a dictionary into a data frame because that's what the model accepts. Model does not accept this plain dictionary. You have to convert it into a data frame. So basically, this would become something like this, right? As you know what, let me remove this one. So it is something like this, right? So model has to accept this one. Now let's say predicted price is equal to model dot predict, and then I would pass the test data frame. So let's see what it predicted and let's print out the predicted price. So it has completed the process and it has predicted 32.77000306. So let's see, the value is 0.0276, 0.02. No, this is not correct. This is not the so we predicted this pricing on the 22 number of the let me just I'm very confused with this. The 22. Where is 22? No, you know what? Not this thing. Yeah, so this there is 22. This is the 22 data that we used, right? As you can see here, the 4.32, which is here. Then we have 395. So this is the data that we used. So the actual value of the this housing median is $30,000, right? And what our model predicted closely, as you can see, that $32,000. So there can be a lot of reason why it predicted like a little bit of higher value. Like maybe there were some uncertainties in the data, or the data was not kind of in a standard scalar. As you can see, we have 40, then 0, then 75 to 0, 0.4. So it was unable to, scale down the data to a common scale. Like, for example, it's between 0 and 1. So that's why it was unable to do it. Maybe, I'm not sure. So then you know what? Let's predict the accuracy of the data, sorry, of the model. So I'm going to import the matrix from the sklearn, which is the confusion matrix, and sorry, it's not and the classification report. I want to check what is the accuracy of this model. So I'm going to pass the confusion matrix, sorry, the classification report, and I'm going to pass the actual values, which are the y-test, and then the predicted values, which are the predictions. No, I think we are passing the wrong values. Continuous is not supported. You know what? Let me just check it again. Y true, and then we have predictions. Why is it not working right now? I'm not sure. Continuous is not supported. What does that even mean? You know what? Let me try the confusion matrix. If this is working or not. No, it's still not working. I'm not sure why it's not working. It should be, but let me check the. Maybe I think the model has some built-in function where we can predict the accuracy of it. Score. Let's see what score has. No, there's nothing in score. No. You know what? Let me pass these two and check it. So you have to check the online documentation for it in order for this to work, because I'm not sure why it's not giving me this data. I have tried with a lot of the models, and this function, it works totally fine. But I don't know. Maybe there are some issues with it. And although there shouldn't be any issues, I mean, I'm just printing out the confusion matrix, and it's saying, you know what, let's search this one for confusion matrix. God continuous is not supported. Yeah, this is the same error. Uh, yeah, so we cannot use the classification report on the linear regression model. So it is only for the classification. So classification dot score X test and Y test. Okay, that's kind of a new thing for me. I mean, I have been doing this for like, I don't know, for a lot of models, and this error was never there. But let's just check it. The Y test. Let's see what is it. Model dot. So we are not going to use this. We are going to say that model dot score. Yeah, so as you can see, the accuracy of this model is, so I don't know why this confusion matrix is not working for the linear values. So values that can increase or decrease, maybe it's for the classification or something like that. I'm not sure. You can search it out. But anyways, the accuracy of this model is 72, right? Which is not good. So the good would be something close to like 85 or maybe 90. So in our case, it's 72. That's why you can see that the original value was 30, and it's giving us this value, 32,000, right? So this is how you can predict. you can provide more data. As I said, that the booster housing has testing and training, and you can basically use the testing over here uh, in the place of the where is it? Where is it? Like the for the testing purposes, these X test and Y test, you can use the testing and the training, but I'm not going to use it. It's a lot of kind of a huge process, so I'm not going to do that. I just use the X-train data set, and basically we predicted this value, which was basically the pricing of the housing in that certain area. So we provided with them with some values, and then it um, predicted us as a simple price. So you can change these values. These are values, and these what does this column means? As I have mentioned this in the starting of the notebook. I will provide the link of this notebook in the description. You can check it out. And if you have any questions, please let me know. Okay. Thanks.